Good morning, everybody. I hope you're doing well. Bye. We are going to start a new kind of unit right here. We're going to get into counting and probability. We just covered a lot of things in statistics and data analysis. And after statistics, natural progression is from statistics to probability. But before we can get to probability, let's talk about ways of counting things. So on your way to school, you decide to stop and get gas. I know you don't drive yet, but one day this will be true. There's three ways to get from your house. I forgot to do a little door with some windows here. You're like, get me out of here. I've been stuck in my house. All right, three ways to get from your house to a gas station. Yes, there's my car right there. These are gas pumps. Yeah, deal with it. And then there's two ways to get from your gas station to Watchung Hills High School. How many routes are there to do this? Well, if I do this a long way, I could do A and B, B and D, C and D. That's three ways. Then I could do A and E, B and E, and C and E. That's another three ways. Uh, 3 plus 3 is 6. Is there another or shorter way to do this? Yes. How many ways are there to get from school to the gas station? 3 ways. How many ways are there to get from the gas station to school? 2 ways. What can I do with 3, 2 to somehow also equal 6 ways? And multiply them. Ta-da! That, my friends, is called the fundamental counting principle. If there are m ways to do one thing, that's like 3 ways. And there are n ways to do another thing, that's like 2 ways. There are blank ways to do all those things. I can just do m times n. And ladies and gents, this can work for more than 2 options. I can have 3 options, 4 options, 5 options, 10 options. Does not matter. The fundamental counting principle basically just means multiply stuff. Okay, so let's get to it. You decide to take your mother out for Mother's Day, which just happened, to a fancy restaurant for a prefix menu. Prefix means you have a specific appetizer, entree, and dessert. On that day, there's 3 entrees, 4 desserts, and 6 drink options. If you plan to order an entree, a dessert, and a drink, how many choices are there? Well, let's think about this. I'm going to do a dash for each thing. One dash represents the entrees, ENT. The other one represents the dessert, and the third dash represents the drinks. Above these dashes, always, and I'm going to go back on screen for just a second here. The dashes represent choices. Above each dash goes the number of choices. All right. Obviously, you're only picking one entree and one drink and one dessert, unless you're really hungry. But it's the number of choices of entrees. How many choices of entrees? 3. How many choices of desserts? 4. How many choices of drinks? 6. What does the fundamental counting principle tell us to do? Multiply all these options. And you have 12. 3 times 4 is 12. 12 times 6 is indeed 72 options. And that's it right there. 72 options. Ooh, yeah. John's security password, must contain exactly 4 letters. How many different passwords can he choose from if he does not use a letter more than once? So he's using 4 letters in the password. It's funny. There's a large percentage of the country who do not know the answer to this question. How many letters are there in the alphabet? If you guessed 26 letters, you're correct. So I'm going to do 4 letters, 4 dashes, 1, 2, 3, 4. Okay. He cannot use a letter more than once. So that's like having 26 letters, each on a piece of paper separately, in a hat. How many letters are there to choose from on that first grab? I'll come back on screen for this. Visual. I'm reaching into a hat. How many letters are there to pick from? 26 letters. But once I've chosen that letter, I can't use it again. So do I put it back in the hat or the bowl, or do I toss it aside? I toss it aside. So how many letters are there in the hat for the second pool? Only 25. For the next pool, only 24. And for the final pool, only 23. What does the fundamental counting principle tell us to do? It tells us to multiply. I'm going to use my calculator here. So I'll do 26. Do 26 times 25 times 24 times 23. And I will get 358,800. And I hope I didn't just screw up and overwrite a program going on right there. And I'm going to put a word right now. Let me go back off screen. I'm going to add a word. It looks like a complex word. It's not. Permutations. Nearly 359,000 permutations, or 359,000 unique 4-letter passwords. That's a lot, just by choosing 4 letters right there. And there is a shorthand way of doing permutations on a calculator, or just writing it out. There's 26 letters to choose from, and I write P for permutation. I'm only choosing 4 of them. This is a shorthand way of writing those dashes. We're going to get into permutations later this week, but I just want to show you that's what a permutation is. It's just those dashes right there. How many different phone numbers can exist with the 908 area code? So it's 908, and then it's going to be dash, 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 dash. Okay, so big question. Can numbers or digits repeat in a phone number? The answer is yes. How many digits are there? From 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Count them all up. That's 10 digits. If you're not sure? Count them up. You'll prove it. It just says that the phone number cannot begin with 0 or 1. So for this first digit right here, cannot equal 0 or 1. So there's 10 digits usually to choose from. But if you can't use 0 or 1 in that first digit, there's 10 minus 2, or 8 possible things, 8 possible digits. Does it matter what goes in the remaining digits? No. Matter of fact, do a anonymous show of hands right now. Raise your hand if, I don't want to know anybody's phone number, raise your hand if your phone number has repeating digits, and mine does. My first 3 numbers are 334. Boom, boom. You get a 1 in 1,000 chance of guessing my phone number after that. Okay, so with that said, let me go back off screen. You could use any of the 10 digits in any of the remaining spots. So if I do an 8 with 1, 2, 3, 4, 5, 6 zeros, that's 8 million, and I'm just going to abbreviate, permutations right there. There's 8 million phone numbers. It's a lot of phone numbers. How many 3-digit numbers can be formed from 1, 2, 6, 7, 8, 9 if no digit may be repeated? So you know what? That's an important thing about this right here. No digit may be repeated. And it's a 3-digit number. So 3-digit number, 1, 2, 3 dashes. How many numbers do I have to choose from? 1, 2, 3, 4, 5, 6. So I put 6 numbers in a hat. How many numbers can be chosen from in the first pull? 6. This is huge right here. I'm coming back on screen. Does this 6 that I'm circling represent this number 6 that I'm circling? The answer is no, it does not. This 6 represents the 6 choices. Look what I'm circling on screen, the 6 choices of numbers. Obviously, you can only put one number in that spot. I get it, but it's not about the number you place there. It's about the choices of numbers. The dashes represent choices. I'm trying to beat, notice how many times I say that, I'm beating us in. So, but no digit may repeat, so pick one. You know what, I'm gonna pick the number 2, cross it off then. Now how many total numbers are left? Only 5. Cross another number off. How many total numbers are left? 4. What does the fundamental counting principle tell us to do? It tells us to multiply. So 6 times 5 times 4, or 6 times 5 is 30, 30 times 4 is 120 permutations. The only time you can write that P notation is in the cases when you start with a number and then you work your way down when there's no repeats. That's why I didn't do any kind of P notation for number 3, because the numbers did not go down as you went to the right. So only when there's no repeats. So how many numbers were there to choose from? 6. P. How many numbers did I actually choose? 3. For the 3 dashes. Represents 120. How many 3-digit numbers can be formed from 3, 4, 6, 8, 9 if digits can be repeated? All right, so 3-digit number again, 3 dashes. Okay, so there's 1, 2, 3, 4, 5 total numbers there. So I've got 5 choices of numbers on the first. But then what do? I take that number that I just chose, and because digits can repeat, I put it back in the bowl. So I can use it again. So I've got 5 choices for the second pool and 5 choices for the third pool. So 5 cubed is 125 permutations. I can't write the p notation like I did for this one here because their repetition is allowed. You can only write that p notation when repetition is not allowed. Okay, but I can write the dashes at all times. Old Navy offers a wider selection of sweaters than in store. This year, they're selling sweaters in 6 colors, 3 fabrics, 4 necklines, and with or without buttons. How many different sweaters are available? Ooh, I look at this, and you know what I see? I see 1, 2, 3, 4 dashes. Why? Because one dash represents the colors, another dash represents the fabrics, another one represents the neckline, and then buttons. My buttons, my 3 groovy buttons. How many colors are there? 6. How many fabrics? 3. How many necklines? 4. With or without buttons? That's 2 choices. Fundamental counting principle? Multiply. By the way, you don't have to multiply in order. 6 times 2 is 12. 3 times 4 is 12. And 12 times 12 is 144 total choices. Permutations. Permutation just means specific way to do things. We are not going to do number 7. It's right now. We are not going to do number 8, although today at least. Maybe we'll get to them on Wednesday or Tuesday. We're not going to do them on Monday. And now here's one I want to go through. How many different batting orders can a softball coach make for a 9-person softball team? So batting order 9-person. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you're not sure, if you're not familiar with baseball or softball, a batting order consists of, let me go back on screen one more time. A batting order consists of 9 batting positions, okay? And you're not allowed to bat again until it's gone through the entire rotation. Okay, so 9 batters, 9 dashes. It's a 9-person softball team. So that means how many people can be chosen to be in the leadoff spot? 9 of them. But then that person can't bat again until it goes around. So then there's only 8, 7, then 6, 5, then 4, then 3, then 2, 1. And what we've got here is something very unique. I multiplied my way all the way down to 1. Whenever you multiply your way down to 1, you can always write this shortcut, 9. And then yes, it looks like it is an exclamation point, but it's not. It's not a very excited 9. It's not 9. It's not 9. Very excited. It's actually called 9 factorial. That's what this is right here. And fundamental counting principle means you're multiplying your way all the way down to. Would you like to know how to do this on your calculator? Of course you would. So I'm going to go to my calculator feature, and I'm going to hit 9, and then everything goes off the math button right here. See the math button right there? Hit it. And then I'm going to scroll, and I'm going to arrow over to probability. Now look at option 2. Oh, that's NPR. That's what we'll do that in a second. But then option 4, that's the factorial button. Hit enter, and 9 factorial pops up. Cool beans. 362,880. I'm going to go back to my sheet here, and I'm going to write 362,880 batting lineups. Holy moly guacamole, permutations. Permutation is a very specific arrangement. If I change 2 batters around, I get a brand new batting order. So think about how difficult a coach's job is. Only with 9 players on a team, there's nearly 363,000 batting orders. Crazy, right? Let's go back up. What if instead of writing 6 times 5 times 4, I wanted to do 6p3 instead? How do I do 6p3 on my calculator? Let me show you. You type it the way you see it. So you hit 6, then you go to math, then you go over to prob. This time you go down to option 2, NPR. So 6p, and then hit 3, and hit enter. 120. Did we get 120 when we did it a moment ago? We did. How cool is that? So you could do your dashes if you want to, or you can do your shorthand notation. You've just learned two new things on your calculator. How cool is that? Okay, so there's factorial notation, means multiplying from a number down to 1. So an example, 5 factorial equals 5 times 4 times 3 times 2 times 1. So that's 20 times 3, which is 60. 60 times 2, which is 120. One last thing. This is huge. There's a rule. 0 factorial. What do you think it equals? Pause it. Google it. It equals 1. What? So if you ever see 0 factorial, almost like raising something to the 0 power right now, but 0 factorial equals 1. You can practice these on your calculator. Let's try one like this. What if I do 7 factorial divided by 2 factorial? How can I do that on my calculator? Well, I'll show you. So here we go. I'm going to do 7 math. I could actually arrow to the left if I want to, and then just hit option 4. 7 math, PRB option 4, divided by, what was it, 2? 2 math, PRB, option 4. 7 factorial divided by 2 factorial, 2520. 2,520. Last but not least, what if I want to do 6 factorial divided by 2 factorial? Unfortunately, there is no shortcut for factorial. I know 2 times 3 is 6, but 2 factorial times 3 factorial does not equal 6 factorial. Why not? Because 3 factorial is actually 321. 2 factorial is 21, so you can't simplify it. What you can do is you can slap parentheses around them and then put it in your calculator that way. Watch, I'll show you what I'm talking about. I'm going to do 6 math prob option 4 divided by, anytime you divide by more than one thing, you must start with a parenthesis. 3 factorial, so 3 math pre-LB option 4. And then I could just do 2. I don't have to even hit times. Math PRB option 4. And make sure you hit enter. And there you go. It equals 60. How cool is your calculator? We're not going to do 13. We're not going to do 14 today. How many ways can 6 books be placed side by side on a shelf? 6 books, 6 dashes, right? So that's 6 books, but once a book's on a shelf, once a book is on a shelf, it can't be on there again. So 5 books, 4, 3, 2, and 1. Ooh, that's easy peasy, lemon squeezy. That's just 6 factorial. Just for kicks and giggles and knowledge purposes, since I'm going down by 1 each time, I could also write this as 6, because that's how many books there are, P. And how many books am I choosing? I'm choosing all 6 of them. Whoa! You know what that means? That means the dashes here down to 1 represent 6 factorial, which also represent a permutation. Wow, that's crazy, yo. And 6 factorial happens to be 720 permutations. Okay, 8 waiters, 8 tables, only 1 table per waiter. I'm just going to say it. That's 8 factorial. 8, 7, 6, 5, 4, 3, 2, 1. How many 5-letter words can be made from the letters in North? How many letters are in North? 1, 2, 3, 4, 5. So 5 letters, 5-letter word. That's factorial. 5, 4, 3, 2, 1. No letter may be repeated. Or this could also be 8, P8. This could also be 5, P5. You dig? Get what I'm saying here? All right. How many signal flags? I'm sorry, how many signal, if a signal consists of 5 flags arranged in a row, how many signals can be made from 9 flags? So you have 9 flags to choose from, but you're only doing 5 flags. 5 flags, 1, 2, 3, 4, 5 dashes. How many flags could be pulled up the flagpole at first. There's 9 to choose from. Once it's up there, it's up there. So there's only 8 flags left, and 7, and 6, and 5. Another way to write that is P notation. You have 9 flags to pick from, but you're only choosing 5 of them. You know what? I'll do 9P5 on my calculator right now, just as one more practice thing. I'm going to do 9, then math, then go over to prob, and choose option 2 this time, and 5. 9P5, 15,120. So that's 15,120 permutations. Okay. I am going to cut it off right there because it's starting to get a little redundant. One last thing, 22. This is one that gets a lot of people. How many different ways can 6 multiple choice questions be answered if each question has 5 choices? Ooh, some might think, well, that'd be 6 times 5. And 6 to the 5th power. Well, I don't know. Let's see. There are 6 questions. 6 questions. 1, 2, 3, 4, 5, 6 dashes. Every question has 5 choices. That's like A, B, C, D, E. So it's A, B, C, D, E for the first question. A, B, C, D, E for the second question, and the third, and the fourth, and the fifth, and the sixth. So it's not 5 times 6, it's 5 raised to the 6th power. And how do I do that? Well, let me just go to the calculator here. So I can do 5 and to the 6th power, enter, 15,625. 15,625 options. So imagine you're doing a 6 question multiple choice and you haven't studied. You have a 1 in 15,625 chance of getting 100. The odds are not in your favor. Okay, everybody, if you have questions, ask. Bye.